I invite you for our next session. And now we are starting our second session of the workshop Method, Resources and Technologies of Open Learning and Research. And this section is devoted to cloud technologies in open learning and research. Uh, I'm very glad to meet you today. That we may continue our work. That I'm very happy that our workshop is going on. That we all are today in touch. That is very nice. I think that someday we will be able to meet in person, but still our community is here. We may meet each other. So this is a very good reason to start our conversation and our presentation. So I invite for presentation our next speakers. They are Irina Drach, Alexandra Borodienko, Olga Petrov, Irina Regeila, Natalia Baziluk, Alena Slobodyanek, and Alena Kuzminska. Please, you are welcome.
Mm, do you see the presentation?
Well, yes, I see.
Yes,
Please start it.
thanks. Thanks a lot. Dear colleagues, dear organizers, I'll introduce the research output on the use of research infrastructures within the realm of open science, the case of Ukrainian higher education institutions. The presentation structure is disclosed at the slide. To start with, I should tell that the imperative for the development of research infrastructures in Ukraine has emerged in response to the tasks of facilitating sustainable socioeconomic progress and fostering scientific advancement, enhancement of contemporary facilities and equipment, research infrastructure of scientific and higher education institutions, fostering scientific collaboration with foreign education institutions while integrating into the European and global research areas, and promoting scientific and technical cooperation through the exchange of scientific and technical knowledge as well as the exchange of researchers and technicians. Nonetheless, the full-scale invasion of Russian Federation to Ukraine on February 2022 has markedly impeded the successful realization of these goals. Under the present circumstances, preserving the nation's scientific and research capabilities hinders upon advancing digital transformation in education and science. These measures entail the realization of comprehensive ecosystems comprising diverse digital solutions, including digital learning tools, online courses, electronic educational content, and various digital resources and services. Moreover, this paradigm needs the digitalization of processes in services, increase in the level of digital competence among the educational process participants, and the automation of data collection and analysis. Significant in this context is the need to rethink the role of content of research activities of Ukrainian higher education institutions and their value, organizational, and functional transformations. Higher education institutions have a crucial role in ensuring the processes of transition to the standards of open science through research, practical implementation of scientific results, and scientific education. The reliability of obtained research results hinder the appropriateness and relevance of the employed research methods, which serve the purpose of identifying the research problem, analyzing the theoretical framework, and asserting the current state of research on the identified problem within both foreign and domestic scientific domains. A comprehensive array of sources, including national legislative and regulative acts on the development of open science and research infrastructures, underpin the study. Additionally, program documents from the European Union were analyzed to provide insights into European policies relating to the focal subjects. The study empirical phase involved serving together insights into critical research inquiries. Specifically, the survey aimed to investigate the current state of organizational support for research infrastructure within the realm of open science at the institutional level, and to discern the distinctive characteristics associated with utilizing research infrastructure services in Ukrainian higher education institutions. An online questionnaire titled Open Science in Higher Education Institutions of Ukraine was developed to gather data from higher educational professionals. The questionnaire comprised both close-ended questions offering predefined answer options with the possibility of either single or multiple choice, or open-ended questions allowing participants to provide detailed responses. The theoretical model of the research infrastructure ecosystem in Ukrainian higher education institutions, with the authors of this study substantiated, predicted the mentioned questionnaire. The model aims to ensure the effective functioning of each component and the overall ecosystem of open science.
I'm sorry,
Within this model,
dear Natalia, presentation doesn't change.
doesn't change.
Yes, презентація на першому слайді.
And now the second one.
Second one, yes.
And now
Maybe still the second one. Yeah.
the second one, but why? Maybe I'll change. Can I show the PDF of the presentation?
Well, okay.
Okay. Thanks a lot. I'm really sorry. The screen is full, and I didn't mention that it doesn't change. So on the model of research infrastructures ecosystem. The model aims to ensure the effective functioning of each component and the overall ecosystem of open science. Within this model, each component of open science, including open data, open access to publications, citizen science, education and skills, research responsibility and integrity, and research performance evaluation, is represented by corresponding services. The services encompassed with the ecosystem include communication and networking services, platforms for content sharing, data processing, storage facilities, and learning management systems. The model
Please,
reflects
maybe you may make a full screen to make it a little bit scalable. Oh, okay, that's okay.
Better?
Please continue, please.
Thanks.
Yes.
Thanks, dear Maria. Thanks. The model reflects the primary directions of policy formulation and development of research infrastructure ecosystem for open science in Ukrainian universities. It creates opportunities for researchers to actively engage in open science processes at all stages of their research endeavors. Empirical data collection took place from March 21 to April 3, 2023. A target sample type was used, employees of higher education institutions to conduct the survey, heads of institution structural units, academic and research staff, library and IT workers. The source base for the target sample was the Register of Subject Educational Activity, Higher Education Institutions of the Unified State Electronic Database on Education of Ukraine. The survey engaged participants from 110 higher education institutions, spanning various regions of Ukraine, except of the occupied territories of Crimea and Donbass. Notably, higher education institutions of the Kyiv region had the highest participation rate, with 17 institutions, including 7 from Kyiv. Other well-represented regions included Kharkiv, 20 institutions, 12 institutions, Odessa, 10 institutions, Lviv, 9, and Dnipropetrovsk, 8 institutions. The total number of respondents was more than 1,500. Let's go to the next section on the organizational support provided for research infrastructures within the realm of open science. Based on the comprehensive analysis of survey data, the findings reveal that most higher education institutions have taken steps toward establishing dedicated structural units or adopting personnel responsible for developing and maintaining the research infrastructures. However, it is noteworthy that a considerable proportion of respondents expressed a need for more organized efforts, indicating that academic and research staff rely on publicly available tools, resources, and services for the research activities. Notably, respondents from higher education institutions in Kyiv demonstrated the lowest level of satisfaction with the organization of such initiatives. Survey data reflect conflicting results regarding evaluation organizational support by different categories of respondents. The survey results revealed that a significant proportion identified the appointment of staff responsible for development research infrastructure within their institutions. The evaluation of the provision of unique tools, sources, and services tailored to facilitate specific higher education research activities is of a particular interest. Notably, differences in evaluation were observed among employees holding various managerial, research, academic, and support positions. Respondents with different characteristics such as scientific degrees, academic titles, and research performance demonstrated divergent views and deviated significantly from the average values observed in the sample. Now we'll go to the part on the use of services that constitute the research infrastructure ecosystem within the realm of open science in higher education institutions of Ukraine. Concerning the open access to publications, our study findings revealed that most respondents rely on institutional and subject repositories and National Repository of Academic Text. Notably, popular subject repositories include the Digital Library of the National Academy of Educational Sciences of Ukraine, as well as university repositories. It is worth mentioning that a smaller proportion of higher education institutions use international services such as Open Research Europe and Directory Open Access Journals. Additionally, a few respondents reported on the use of other services, including the Directory of Open Access Books, Open AR Validator, Figshare, Zenodo, and EpiSciences. The respondents highlighted the use of open journal systems as a platform for publishing scientific periodicals and other systems for the repositories. Notably, respondents' answers shed light on the challenges faced by several hosting institutional repositories which have suffered damage due to the military actions. These challenges underscore the urgency of providing informational, educational, and advisory support to staff members in higher education institutions, particularly young researchers, to enhance their effective use of existing international services. In the context of storage and management of open research data, institutions predominantly rely on using open science framework. Additionally, a lesser proportion of institutions make use of Mendeley data, Figshare, and Zenodo. Our analysis revealed that various factors such as job position, publication record, research performance, the field of knowledge, institution location, and institutional scope notably influenced the survey results. A detailed examination of the findings concerning utilizing the infrastructure services for storing and managing open research data revealed striking disparities among respondents with different research performance level. One significant observation that requires particular attention that is the limited awareness among respondents regarding open data storage and management services. Nearly 30% to 455 individuals reported that it's difficult to answer, I cannot say, I didn't get information or lack information. The professional development of research and academic staff, specifically in terms of educational skills, primarily relies on utilizing various services. Our findings indicate that the most commonly employed platforms for this purpose include Moodle, YouTube, and to a lesser extent, edX. A notable proportion of respondents could not answer the question regarding the services. Moreover, it's evident that the characteristic of the respondents, such as position, scientific degree, academic title, and research performance, influence their assessments. Unicheck and strike plagiarism emerge as a primary tool to enhance research responsibility and integrity. Relatively less prevalent were crossref similarity check, WeCopy find, and anti-plagiarism. Respondents in comment section underscore using the services primarily to scrutinize students' qualification papers. It is noteworthy that a significant proportion of respondents demonstrated a limited level of awareness according the services employed by higher education institutions to promote research responsibility and integrity. In higher education institutions of Ukraine, various services are utilized to evaluate research performance. The predominant services include ORCID and Google Scholar, which are widely adopted for this use. Additionally, institutional subject repositories are commonly employed. The bibliometrics of Ukrainian science. Other services that contribute to research performance evaluation in these institutions are Open Ukrainian Citation Index, Directory of Open Access Journals, Impact Story, Directory of Open Access Books, Allmetrics, Open Science Observatory, DataScience, and Plemex. In the context of citizen science development, higher education institutions of Ukraine use various services. The most prevalent among them is Science to Business, an online platform facilitating communication and effective interaction between the scientific community and business representatives. Other notable services are Impact Story, OpenAir Connect Dashboard, Allmetric, DataSite, and Plemex. Among the respondents, academic staff heads and deputy heads of structural units and heads and deputy heads of institutions rate the use of science to business service higher compared to employees of IT departments, research staff, and library workers. Now we'll go to the conclusions of our study. The full-scale invasion of Ukraine by the Russian Federation on February 2022 has had a detrimental impact on advancing research infrastructure in Ukraine, spanning the national, regional, and institutional levels. Nevertheless, the establishment, management, and efficient use of open science research infrastructures remain essential prerequisites for bolstering the research capabilities of Ukrainian higher education institutions. Despite the considerable progress made in the national level open science policies, the institutional landscape reveals a certain fragmentation in implementation comprehensive open science policies, including policies regarding the infrastructures. Many higher education institutions need more relevant policies within their development strategies. In the contrast, the leading universities of European Union prioritize implementing open science policies and operationalizing organizational, advisory, and institutional support system for researchers. The current state of organizational support for research infrastructures in Ukrainian higher education institutions need to be improved. The provision of researchers with unique resources and services aimed to facilitate the specific research needs of each institution still need to be completed. While some institutions have established dedicated structural units or appointed responsible individuals to oversee the development of research infrastructure, many institutions need more organized efforts. Consequently, research and academic staff in the institutions rely on publicly available facilities, resources, and services for their research activities. The level of awareness and engagement in developing research infrastructure is relatively low among employees of IT departments and library workers, noticeably lower compared to other categories of staff. Furthermore, there is a notable discrepancy in the perception of the existing research infrastructures within the realm of within the sorry. I'm sorry. While some institutions have discrepancy among individuals with the educational community of Ukrainian higher education institutions based on their characteristics such as scientific degree, academic title, and research performance. The findings indicate that individuals with higher scientific degrees tend to possess more comprehensive knowledge across all aspects of research. The respondents overwhelmingly rely on institutional subject and national repositories to facilitate open access to publications. However, the use of international services remains significantly limited. The unfortunate damage inflicted upon services hosting institutional repositories due to the military operations emphasize the necessity for comprehensive measures to provide informational, educational, and consulting support to personnel within these institutions. The limited level of awareness among respondents regarding services related to the storage and management of open data, the promotion of research responsibility and integrity, and the professional development of research and academic staff present a distinct challenge. There is a need for initiatives to enhance awareness and understanding among respondents and these crucial aspects of open science. A notable observation pertains to the limited use of services to enhance research responsibility and integrity. The results of our study support the imperative for establishing a pervasive culture of open science at the institutional level, necessitating a concrete effort to drive its implementation. There is an urgent need to enhance key normative documents of higher education institutions, including strategies, plans, and roadmaps, explicitly articulating the mission, goals, and objectives of integrating open science principles to achieve this. Furthermore, the systematic functioning of research infrastructures and relevant resources and services must be substantiated and ensured for effective operation. It is crucial to prioritize appointing highly competent professionals to administer and manage research infrastructures within these institutions. This appointment will facilitate the seamless functioning and optimization of these vital structures supporting open science. A well-crafted communication policy adopted by higher education institutions is pivotal, and elevating employees' awareness concerning open science policies and procedures and facilitating access to research infrastructures. Moreover, it is prudent to actively engage employers of IT departments and library workers in the operational and supportive aspects of research infrastructure. In this view of these considerations, we emphasize the importance of instituting proactive measures within institutions to enhance the research competence of research and academic staff. By adopting a constructive approach, higher education institutions can continuously elevate the proficiency of their academic staff, fostering an environment conducive to impactful research practices. Thanks for your attention.
Thank you very much. Very interesting and remarkable report, because you see that our workshop is devoted to open education and open science, and this trend of open science now is rising, and now we have several reports devoted to it, and this is peculiarity of this workshop, so I'm interested. Well, maybe you have some questions. You're welcome. Maybe you just have a little bit to think over. And as for me, I'm interested in for me, this is remarkable report because we really have not very much investigations devoted to it in Ukraine. And now, what do you think? Where are we in the progress, in our progress and transition process to European research area and research and educational European area? Are we on the very beginning, or maybe there are first steps? And what practices do you think? What practices of open science are the most the most urgent to be introduced into our Ukrainian research and educational environment? In what we are maybe behind, and in what maybe we have advantage? What do you think?
Thanks, dear Maria. I think that Ukraine and Ukrainian, not institutions, but I think the Ukrainian researchers have made lots to come with the open science principles and values, and they are really important for us, and they are really useful for us, especially under such circumstances, under the war. The open science is really important, and not only to present our research outcomes, but also to see the research outcomes of other researchers from other countries, the European countries and the world ones. There are different. I think, as we mentioned in our publication, the stage of implementation is different. There are some points at the national level, but there is a need for some for more institutional acquirance. Um, uh, as for me, compared to the European colleagues, for example, they are suffering on presenting the open access to publication, and this is really a problem, how to, what licenses to use and what to do and how to make it. But in Ukraine, mainly, no, I should tell, in the system of the National Academy of Educational Sciences, most of the 90% or even bigger part are presented openly. And in such case, we support these open science initiatives for more.
Thank you. Thank you. There is really optimistic yeah, thing.
It should be.
Well, that we also have our advantages. That is really nice. And of course, this is important trend. That's I think it will be developing further. Maybe there are more questions or not. Well, and thank you very much for this very just uh, inspiring and very important report. Uh, it was very interesting for me, and I think for our auditory. And now we will pass over to the next report, and also we will continue discussing the questions of concerning to open science and open science activities. And now, uh,
Thank you, dear Maria. Thanks to the organizers and the participants and my co-authors. It's what's really interesting and very challenging to present the materials for such a high-level conference. Thanks a lot.
thank you very much. Okay, and now the next report. Ольга Гуляй, Halina Gerasimchuk, and Vitaly Kabak. Please, you're welcome to start your presentation, and you have 20 minutes for your report and questions. Please.
Thank you. One moment.
Okay. Okay. There is a
One
presentation.
moment, please. Dear colleagues, I'm Olga Hulay, professor of the Lutsk National Technical University, and I want to present a topic, Principles of Open Science in the Activities of Technical University. Open access to knowledge is an inevitable trend in the modern scientific world. The term open science is gaining popularity. Google Scholar search engine gives more than 36,000 links in Ukrainian and more than 9 million in English. Among the numerous long and short interpretation of this concept, we choose the one presented in the review by Vincent Sayce. Open science is transparent and accessible knowledge that is shared and development through collaborative networks. The application of open science principle has a great potential to accelerate the research cycle of global human problems in 21st century. This is recognized by a number of recent documents of such World Integrament Organization as the European Commission, the European Parliament, the European Council, the Organization of Economic Cooperation and Development, the United Nations, and the World Bank. Open science should help reduce inequalities in access to scientific development, infrastructure, and opportunities between different countries and researchers, regardless of gender, nationality, or level of financial security. Such open science concern A. Scientific publication, open access publication platforms, B. Research data made available in accordance with the findable, accessible, interpretable, and reusable FAIR principles. C. Educational resources to be realized with open license permits that enable no-cost access, use, adaptation, and redistribution. D. Software to be released under a license that allows modification, derivatives, and sharing. And even e-hardware, such as design specification of apparatus, tools, and samples. Despite the hostilities, the Ukrainian scientific and educational space is also implementing the open science implementation strategy. Decree of the Cabinet of Ministers of Ukraine on approval of the National Open Science Plan on October 2022. In leading European universities, there is a transition from a narrow understanding of open science as open access to scientific source data and software to considering it as a special environment in which partnership and combination between scientists, social, and business. As an example of the best university practice of implementing the principle of open science, we give the mission and vision of the Open Science Program at Utrecht University in Holland. Uh, active implementation of the principle of open science at Lutsk National Technical University is associated with participation in the Erasmus Plus KA2 project, open practice, transparency, and integrity for modern academia, Optima. The main goal of the project is to implement the ideas and practice of open science in order to improve the quality of educational service in Ukraine. The Optima Consortium is also included Vasil Stus Donetsk National University, Sumy State University, Lutsk National Technical University, National Antarctic Scientific Center, and the National Agency of Higher Education Quality Assurance. Project's international partners are Graz University, of Technology, Austria, Wrocław University of Science and Technology, Poland, University of Côte d'Azur, France, the European Council of Doctoral Candidates and Junior Researchers, and others. Considering the use of the principle of open science in Lodz National Technical University, we distinguish three main fields: educational process, scientific activity, popularization of open science. The results of the combination of open science and open education are open practice, the components of which are the tools, blog, wiki, learning platform, editing pack, activities, sharing, communicating, discussion, accessing, and resources, data, books, article, presentation, multimedia. Analyzing the educational and scientific activities of LNTU, we give example of each component in table. The openness of the educational environment is demonstrated by the LNTU website. The main educational platform is LSM Moodle. The type of platforms for skill development and self-development contain link to educational resources offering formal and informal learning in all. The main aspect of the concept of open science are included in the educational process. This is a separated topic in the discipline methodology of scientific research for masters and graduate students, or a special discipline, selective or normative, depending on the specialty. In particular, Science 2022 Master studies the discipline Open Science Foundation and Information Management Practice and Open Science Foundation and Practice in Ecology. And graduate students study Open Science. The openness to assessment is illustrated by open range of academic performance of students and the results of a survey on the quality of the educational process. Openness in the scientific aspect is demonstrated by scientific journals of LNTU, whose publications are in our open access. There are scientific journal, Computer Integrated Technologies, Education, Science Production, Economic Forum, Technological Complex, Collection of Scientific Papers, Economic Science and Scientific Notice, Student Scientific Bulletin. An important aspect of implementation the principle of open science is their wide popularization. Informal training on academic integrity and open science are periodically held in the participation of students and teachers. For example, on May 2023, within the framework of the international project Optima, students and school children communicated with scientists from leading universities of Ukraine and participants of the 28th Antarctic expedition, who are currently at the Ukrainian Antarctic Academic Vernadsky Station. Interactive training are an effective method of popularization of open science. In April 2023, there was an exchange of experience of master who took course in open science with undergraduate students. The purpose of the training was to explain the understanding of concept and term used in the educational and academic environment regarding open science, integrity and transparency. A survey was conducted before and after the training. The results of the survey are shown a figure. Most of the bachelor improved. Sorry. Most of the bachelor improved in the training did not know about the term open science and could not give example of the spread of this trend in the activity of LNTU. However, after training, only less than 2% of students were unable to answer this question. The The analysis of LNTU experience allow us to draw the following conclusion. Implementation of principle of open science in higher education institution is directly related to digital cloud technologies. The leading role is played by the university website. The experience of European universities in open science is studied and implemented through participation in Erasmus project and academic mobility. Coordination and conclusion and consulting of certain aspect of open science is carried out by various departments of the university. Scientific project, Department of Quality Assurance of the educational process, licensing and accreditation. Implementation of the policy of openness of scientific research is mostly reduced to open publication in scientific journals and publication discussion of research results and concerns and seminars. Events are being held to popularize the principle of open science for both student and scientific and pedagogical staff. Such, the principle of open science contribute to creation an innovative, open, virtuous, and competitive educational space. Thank you for attention.
Thank you very much. That is very well, very detailed, and more of it. It is in time, so we are very well fit our schedule. Then maybe there are any questions. You are welcome. The questions concerning open science, which is the most current trend in this sphere in European and international educational environment. Well, I'm very much interested in this report also. I think this is really a nice tendency that we have more and more reports on devoted to open science. And here we have the investigation devoted to some international experience. We may even compare these results with the previous discussion concerning more investigation and survey of Ukrainian experience mostly, and here the
Да,
international one. Well,
да, алло, алло.
okay. Um, Okay, so what do you think for technical universities? What practices of open science are the most the most important? For example, open access to publication and research data maybe are valuable in whatever area, for any area, yes. But for technical university, what do you think? What tools, methods, and practices are the most important, the most favorable, please?
Thank you for the question. For my opinion, I think that for staff, for scientific and pedagogical staff, is more important open access to publication. And
Wow.
for student, is more important educational process disciplines that student may be study with his program, masters
Thank you.
or
Mhm.
PhD program.
Okay. Uh, what about the international experience? What do you think? Do they usually use such practices as, for example, for example, when students or maybe in educational process, they refer to uh, the learning tools and technologies from another university and even maybe from foreign universities. What do you think? Is it in international practice? Do they often use it?
I agree with you. International practice is very important, and we need to complete it in our university. We want to very different event in European university in Poland, Germany,
Mhm,
and need to have in Lutsk University start
mhm,
us in Germany, Poland,
mhm,
or Netherlands.
mhm. Okay, maybe you may just remember or uh, tell us about some interesting, maybe some uh, unusual or peculiar or somewhat interesting example of using open science tools for learning in different countries. Maybe some the most interesting for you example of using open science tools.
Uh, no, maybe it's
Maybe from
one of
different
the
universities. Mhm,
example is university in Byron where we
mhm,
be university in Byron that have a very open website of university.
aha.
Students and teachers may have many information and access open access to tools for all work. It's an example for such university.
Ah, thank you very
Excuse me
much.
for my English.
Thank you. Thank
Excuse
you.
me.
No, no, that's okay. We all share experience, and our
Yes.
aim is, you see, to understand each other, to master our communication also. So very nice and interesting experience we got from your report. Thank you. Okay.
Thank you very much for attention.
Thank you. And then we pass over to the
Um,
next report, and we invite Olena Kuzminska, Marie Mazurchak, Natalia Morza, and Maria Prokopchuk. Please, you are welcome. Do you have 20 minutes, please?
Thank you
Mhm.
very much. Can you share my screen now? It's okay. Can you see?
Yes. Okay.
Okay, thank you. Dear colleagues, my name is Olena Kuzminska. Let me introduce our team research named Open Science and Researcher Digital Capability for Improving PhD Student Training in Higher Education Institution. The purpose of our study to determine requirements to PhD students' results and curricula in higher education institution in the contents of the open science development and to field test their effectiveness by the degree of formation of digital competence of research. We analyzed the following documents you can see in this side of slide. And in this context, especially analyzing the European research area documents and European higher education area, it's important to emphasize the role of two agents. Future researchers who high degree readiness for effective implementation, the conditions of digital open science, and a university that meets the requirements of the European research area and the European higher education area. Among other aspects, this involves a change in the learning model. The new model should focus on the development of digital capabilities of future researchers and the inclusion of digital competence in educational programs. Relevant experience is presented in the studies of both Ukrainian and international researchers. In particular, design and reflection of learning open science in educational institution in Germany. We analyzed and finished a researcher's experience of managing open science and innovation in university in a digital world. While for Ukraine, this issue is pivotal in the context of post-war recovery. Not only general, but is very important to improve and development our science and education. And we formulate three main research questions. This question you can see on the slide. The theoretical basis of our study is based on the provision of defining the digital competencies of future researchers and using the DECUM model for curriculum development. Let's consider them. For defining the digital competencies of future researchers, we analyzed the exciting models of digital or information communication competencies and cases of the application in the process of training specialists. These documents, this framework, this model, you can see on this slide. At the same time, it should be noted that today an increasing number of researchers and practicing educators are turning to the application of the DigiCom framework for the formulation of educational policies, planning or training and assessment of the formulation of digital skills. There are also recommendations for the correlation of the mentioned frames, ECDL, and DigiCom, as well as the ECF and DigiCom. This help, for example, to determine the continually and enhancing effect of ECDL and DigiCom when planning the curriculum or the correlation of general requirements of the digital competence for citizens, as well known DigiCom, and IT professional ECF. Then later permits to demonstrate the continually certain skills when moving from the competencies expected of citizens to the competencies that IT professionals should possess. Since none of 30 profiles of IT specialists defined by ECF, which are used for drawing up educational program, correspond to the largest audiences, we say in our research we develop competence of future researchers in university. It's not worthwhile to use the profile of these specialists. Therefore, you can see on slide diagram, taken using DigiCom 2.2 as a basis, we continued our research to the description of the profiles of subjects acquiring this competence by analog with ECF. We compared groups of competence DigiComp and JISC researcher profile. The results of the comparison are present on this slide. At the same time, we should be note that requirements for the digital competencies for researchers have a specialized focus and wider scope. That is why correlation shown in this figure is a certain generalization. For example, information literacy of the researchers is an extension of the equivalent category DigiCom. In particular, in terms of the development of personal digital environment adapted to scientific interests and needs. However, the researcher's digital profile does not specify requirements for solving problems relating to setup, safe use, technical support for research programming, and community outreach. These competitions should be formed at the basic level in every citizen by Digicom framework. This competence is formed in other disciplines in university, different disciplines. Therefore, the presented analysis is a reason to adopt the GISC researcher profile as a basic for determining the requirements for digital competence following the DigiCom framework for future researchers. Think the integration of digital and professional competence in the educational curricula is most extensively studied in the training programs of future IT specialists. In this study, we will try to scale the development methods to the design of program for the training of future researchers at university. In this content, attention should be drawn to the use of a systematic approach of DECUM, development of curriculum. In our research, in terms of labor market requirements, we focus on the training needs of researchers capable to effective implementation in the condition of digital open science, and we consider the descriptions of the digital competence of researchers as the expected results of postgraduate studies at university. It should be also noted that the definition of learning objectives and expected results for design of educational programs, individual course or models requirements, future modification, and introduction of sub-competencies. In this process it's advisable to use the recommendation of DECUM, a model and process we can see on this side of slide, both regarding to the selection of experts and the algorithm of their activities. More details about this model you can read in our article. Therefore, in order to achieve the goals of our research, namely to determine the requirements for the results and training programs of PhD students in higher education institution in the context of development of open science, as well as confirm the effectiveness of the application in accordance with the level of formation of digital competency researchers, we formulate the following tasks. This task you can see and read on the right side of this slide. To solve the research task, we use experts evaluation methods. For solve first and second task, we involve two international experts, in particular among a participants of European project called RNet, about international cooperation and develop digital skills and competencies. And these experts evaluate each of 15 defined DISC research criteria indicators on a 4-point scale. This scale not significant to highly significant. These experts also evaluate contents of content of our authors model, digital technologies in modern science research, learning open science. For the third research type task, we used a statistical survey, online forms presented in our link on forms presented in our article, I'm sorry, and 89 PhD students of the second year study at the Boris Grinchenko Kyiv University took part in their survey. We use them as experts to determine the effectiveness of application. Also, they're also educational models. We choose two groups. 46 of them studied course, this group named experimental, and 43 did not study. This is control group. And as a result of the expert evaluation of the criterion indicators for evaluating of digital competence PhD students based on JISC researcher, the importance of the selection criteria indicators turned out to be varied, but all the determined criteria see on this table turned out to be significant, which indicates the corrections of the application of the digital researcher model for determining their level of digital competencies of PhD students. Taking the experience of integration digital competencies in higher education curricula as a basis, we carried out a comparative analysis of educational programs for PhD students in Ukrainian institution of higher education in general and Boris Grinchenko Kiev University in particular. As a result, we should be note that the digital capability of future doctors of philosophy are purposefully formed by teaching the mandatory subject scientific research studies. In accordance with the second task of our research, the model Digital Technology in Modern Scientific Research Learning Open Style, 2 credits was additionally developed. In this, mainly aimed at the formulation of the ability to use digital technologies in modern scientific research, starting from their formulation and construction to appropriate information models and ending with the interpretation of the results obtained with the help of computer. The main contents of the model, examples of digital tools studied by PhD students, and list of digital researcher competencies that are formed when study each topics are shown on this slide. At the same time, it should be noted that according to experts, the formulation of digital individual components of the researcher digital competence, primarily in terms of scientific proficiency and productivity, group J1, and identity and well-being indicators of group J6 also required the involvement of PhD students in real scientific research and project. Therefore, these and some others, for example, G 3.2 and G 3.3 and G 4.3 competencies within the optional model can be formed only at the basic level. Comparing the result of the survey of the participants of the experimental groups and the control groups, these results you can see in this slide. It should be noted that the students of the experimental groups showed better results overall. This picture. So we reject the null hypothesis. The likelihood of observation such a significant difference due to random chains alone is extremely low. In order to confirm the influence of the author's methodology, design and application in the process on training PhD students of the selective model digital technologies in modern scientific research learning open science, on the formation on certain competencies in the experimental group and additional comparison of competencies was carried out according to the research related to digitalization, in particular in terms of defining ICT solution to problems that arise in the course of research and scholarly activity, understanding how digital technologies are changing a field of research with respect to questions and challenge, meta theories and values, development and projecting a positive digital identity of identities as researchers and academic integrity at several sub-competitions. Therefore, the self-assessment of PhD student experimental and control groups for component G1 2.2, you can see in this part of slide, students experimental and controls groups and control groups shows, as we can see in the slide, a difference shows difference between two groups. The experimental groups have a higher mean rank of rates than control groups. Similar results, as shown on this slide, we obtained in the results of the comparison of other competencies characteristics of researcher. A more detailed description and calculation are given in our countries. In general, the comparisons drawn speak in favor of the application of development methodology for the competence enhancement of educational programs, or in this case, the development of elective models, digital technology in modern scientific research, learning open science. At the same time, based on the result of additional in-depth interviews with students of experimental group, the need was detected, and similar training practices for using open science to development models of explaining skills in digitalization of conditioned scientific research. This can be implemented by enhancing courses available in the training program for PhD students, or introducing into the educational program a scientific research practicum, maybe international program mobility, and join these students in a real project in university. We can see on this slide our general conclusion. First of all, our analysis of research result in practical cases of basic for determining some key benefits of studying open science for PhD students. As a result, has really a result as access to knowledge. It's very important for PhD students, not on PhD students, but in our case, we say about the same students. Collaboration and networking opportunities enhance reproducibility and transparency, and increase visibility and impact. It's very important for young scientists, for future researchers. And following the analysis of the source database with subject expert evaluation via engaging international expert, we sustain the expanding of applying descriptions, GISC researcher for determine the requirements to digital competency of the future researcher, determine the need for inclusion the digital competence of researchers in curricula for PhD students, and we developed or enhanced existing training model, and we enhanced this by terms of learning open science. And our research and experts evaluation, but our students experimental and control groups show us that our result is useful. I suppose not only students, PhD students of Kiev Boris Grinченко University, but all PhD students and researchers of Ukraine University. Thank you for your attention.
Thank you very much for your profound research and your very detailed presentation. It was very interesting. Maybe there are some questions. Please consider your questions. And as for me, the report is remarkable, you see. And I'm very much pleased that we have such reports, and now we may say not only for some promoting of open science practices, but also experimental results, implementations, indicators of research, and so on. I think uh, this is such a big progress in this direction. So I'm very much interested. As for me, I am interested in the notion of open science competencies. As far as I see from the report, you include open science competencies into digital competencies. Am I right? Yes, and this is very interesting approach. What do you think? Open science competencies, maybe they are wider than digital competencies. Maybe there are some aspects of open science competencies which we may include into the courses of training or digital training. What do you think?
Um, as for me, we not used competencies of open science. We used the framework of DISC researchers, digital competencies of researchers.
I see.
And we compare DigiCom framework indicators because this framework is standard for our country on government level, on
I see.
level, and we try to use methodology, compare DigiComp and ECF framework for future IT specialists, and take some framework for some proposal for use the GISComp researcher competency for our future researchers and PhD students.
I
And
see.
when we analyzed this framework, we can see that competencies of open science, as I know, these competencies
They are not just digital competences. It is something another kind of competencies. You see, we also considered these relationships, and we considered if what is open science competencies, because we also analyzed the framework of open science competencies, and we considered what are they? Something a part of digital competencies, a part of investigative competencies, maybe something between these two parts. you see? And now you consider digital competencies of researcher. For us, it is very interesting. We did not take this aspect. I think we would consider it also, because we tried to match the open science competences and digital competences, and to find some relations, and to consider some open science competencies from this point of view, but we didn't consider the framework of digital competences of researcher. Maybe this will give some more interesting insights into this topic, but still. The classification of these competences, this is really, I think, important trend which is now under investigation. So of course it is interesting to share experience in this matter.
No, I think in this context that we, and you can see our also Professor Natalia more than maybe some comments, but we not improve open science of simple or самостійний model.
Independent model, I see. It is not independent. I got it. Yes, I got this idea.
That's why we don't analyze, don't research open science competency. But it's very interesting theme to future research, maybe.
Yes, for future research, and for us, your research is very interesting, because we did not take it from this point of view, but really we also came to conclusion that maybe most of them, or maybe all of them, are they are concerned to just digital competences, you see, but maybe some peculiar differences remain, and this is the matter of further research. Thank you very much. Maybe there are more questions or not? Thank you. And we are very well in our time table. Well, so thank you for being in time. And now we just pass over to the next report. And that is mine report, and it is, I think, will be the last in this session. Thank you. And now I'll share my presentation. Ой, сюди, так, окей. Так. Весь экран попробуем. Так. Надіслати. Угу. Okay. Do you see my presentation?
Yes.
Okay. Now I'll try to launch it. Oh, now, do you see it? Do you see the whole window?
Yes.
Yes.
Okay,
Yes.
that's nice. That's nice. I would like to present the results of our new project. That was Visegrad Fund project. And this is the joint report with Stefan Svetsky, who is the coordinator of the project from Slovakia, from Bratislava, Slovak University of Technology in Bratislava. So this is the joint work, and we also have other partners in this project, but I will present the joint work. Also, I would like to consider open science services and open science activities, but in such aspect as virtual research teamwork support, which was considered in our EduPod project, where there were representatives from 5 countries, and there was the research team, international research team, and in this project we considered the digital tools, different digital tools to support the activities of this international research team. And we also take it and understand it as the example of open science practices. In our research, we considered a lot of different services, and in this project, some of them were implemented. In our research, of course, we already noticed that open science supposes general availability in digital format without restrictions of research results obtained, for example, by the funds of European projects or state expense. Also, removing barriers to common use of any type of products, resources, methods, tools at all stages of the research process. But we would like to consider open science practices from the point of view of tools and resources of this activity, because these principles of openness pervade the research cycle in all its stages, promote cooperation and exchange of results, which lead to systematic changes in the theory and practice of scientific research. I'm trying to be short, so I would not maybe say everything which you may consider. Simply to remind the principles of open science, the cloud-based systems of open science, which we considered, a lot of them, such as analytical network systems and electronic libraries and electronic journals and repositories and so on. European Open Science Cloud, which is pan-European infrastructure, uh, which just contains some other large infrastructures and their tools and services, and that is our educational academic portal for integrating IT into education project, which started in 2022, and at the beginning of this project it was impossible to be included from Ukraine, but after some time, when just situation somewhat stabilized, just Visegrad Fund decided that it is possible to engage the participants from Ukraine. So we were engaged in this project, just not from the very beginning, but in the middle of the project. But still, we are engaged into it. Here you can see project partners. They are from Slovakia Technological University, also Ostravska University from Czech Republic, then the Center for Intelligent Robotics from Hungary, also the University of Science from Siedlce in Poland, and our institution of digitalization of education of the National Academy of Educational Sciences of Ukraine. So project aims to combine knowledge gained in educational and research institutions of V4 plus countries to create an educational portal, relevant IT software, and common infrastructure for creation of educational packages and multilingual content for this portal. The activity was focused on creating a hybrid IT infrastructure of the project and testing a learning design. It was virtual machine and VPAD software, which is an also software. The author of the software is Stefan Svetsky. It is his development, and this software is no SQL, has no relational database, no XML, although it is a database application for creating personal information or knowledge tables for offline and for virtual machine. Basic level only requires Windows, only basic IT skills, user friendly, and so on. And also EPIX channel as communication channel was used, also elaborated by Stefan Svetsky specifically for this project. So in this project we consider a large number of general services which are available on European Open Science Cloud, on different portals and infrastructures and so on. And of course, we may use these services, but sometimes the tasks of the projects are specific. And it was convenient for us to accumulate all electronic resources in our own portal and with specific educational software to produce these electronic resources and accumulate them. You can see that the problem of generating and user and implementation of electronic resources is very much important in distant and mixed learning because you will need a lot of it. And for this purpose, VPAD tables are used. And from this VPAD table, a user can take an online link to the resources and autonomous path to it without opening the browser. And another important feature is that VPAD table is possible to convert to HTML table and set to web. So it is somewhat automatic tool to produce educational resources which support the work of teacher and supports the supplying educational resources while distance learning. And in this project, we shared just research resources such as publications, sources to different references to different sources, and some other interesting information which may be valuable for researchers. And also another part of this project was to fill the educational portal with educational resources of different kinds, just to share it between participants who are mostly teachers of informatics in educational universities. So to enter the information into VPAD table is very simple. It is simply to input it just as a table in database. And you will get such a library or collection of useful resources. For example, here you can see the table where we collect the information about 130 magazine publications. It was the electronic library of this publications, but to look through this library, you need to open every source and look into it, to go to browser to find this reference and so on. But if you get it in the table, you may simply click by the necessary row and you will see in another window the content of the journal. So it is useful if you try to collect the electronic research resources which may be used in the work of international research team. And here is the library of Google profiles of project participants, and here you can see the this table transformed into HTML format, and you can browse it through internet. And this is PIX communication channel. This is also author software where the research team communicated and exchanged ideas, references, and other useful research sources. And here, this PIX channel you may use through internet. You may say this rather simple tool, but still not not for example in Facebook or other team working, you would have communication channel with different communities, and here it was just specified for the aims of this community, and only this community uses it. And this is, you may see different events which are introduced into this channel. And here is the whole picture where you can see who published this information, and is some information in this PIX channel, and you may see the references and go for it. Thank you for attention. That's always this. And now I'll go again to my screen. Okay. Так. Okay. Maybe you have some questions to this report. You are welcome.
Firstly,
Okay.
many thanks for your useful educational resource.
Thank
And
you.
I have a question. Is this system free? System
Oh,
EduPort, or
you see?
not? Or not? What cost policy
I
of
see. I see. I'll say.
system use?
Thank you very much. This is really maybe the most important question here. We considered it in the context of open science priorities, and decide. And as for me, you see, in previous reports about Ukrainian experience, we considered that we very often in Ukraine we open our resources, and as for international research team, for example, I faced such a challenge that to open the resources is not so easy, and sometimes they don't like it because there are also tools and there are some authors rights for privacy and so on. That's why the policy is the next. In this portal, some resources will be opened. Those which authors are ready to open and to give to open access. And some resources are only, let us say, private, and they will be available for the only for the research team. So this is still open science, but open science which is focused on different communities. And now some resources are focused on the research community. For maybe some research aims to compare experience, to evaluate it, to consider what practices are better, and so on. These are research aspects, and this will be inside the research team. And some part of this portal will be open access.
Thank you very much. Maya Marienko have a question.
Well,
Thank you.
please.
I have two questions.
Well,
What is the contribution of the Institute for Digitalization of Education of National Academy of Ukraine to the implementation of the V4 Educational Academic Portal of Integrated IT into Educational EduPort project?
mhm.
And two questions, what tasks were performed by the Institute? Please give examples.
Okay, thank you very much for these interesting questions. Really, our institution got a lot of materials. Mostly of them were research materials, and as you saw, as I showed it, it were publications of our just. Concerning the topic of the project, and it was the library of the project where some resources of our institutions were provided for our research team to consider it and to compare it and so on. Also, we provided our resources to all the meeting of this research team, which were also integrated into research portal. Also, we experienced the electronic resources through uh, virtual machine. That was the most maybe contribution of our institution because we took part in deployment of virtual machine of the project and in testing this VPET software in the cloud-based environment. And we proposed this idea, provided the methods of employing this virtual machine, and now all the participants tested it and used to this infrastructure. And all this software was tested in cloud-based mode. It was successful testing, and now first this VPET was produced in local version, but in this project it is also is deployed in cloud-based version when it was deployed on virtual machine. Also, we may also we tested PIX channel, communication channel, and this was just specific for Ukraine because we tested it in this situation of electricity lack, and it was successful, and it worked even by mobile only version without Wi-Fi and so on. And this was very nice tool because it is really easy. It is very simple, so it may work even on smartphone, even in some circumstances with lack of some maybe connection or something like that. But still, we communicated through this channel when it was impossible to work on notebooks. But if your smartphone works, you may use this channel, and it was rather quickly worked, and that was okay. So you see, this is a research project. Also, some educational resources also will be produced, but still we took part in this, so to say, research laboratory of evaluating and testing of different kinds of software.
Thank you for your answer. This is very interesting topics.
Thank you.
Many interesting report and many questions.
And Vasily Alexiuk, please, you're
Vasily
welcome.
Alexiuk, please.
Please, you're welcome.
Включите, turn on
Yes,
microphone.
Microphone.
Hello, everyone.
Hello, nice to see you.
Nice to see you and all participants of MROL workshop of ICTERI conference. Dear Maria Pavlovna, thank you for your interesting and on-demand study. As for me, it's very important to organize collaboration between Ukrainian and European research at educational institutions. I have one practice question.
Yes.
It is possible to you for your open science system whole or VPAT table in particular to get data from direct from scientific databases such as Web of Science or Scopus.
I see. You see, rather interesting question. You see, VPAT, it is rather unusual kind of a database. I would like to say so. You see, this is the idea of Stefan Svetsky. You see, it would be really very interesting for me to to discuss it with you. But now in distant mode we have only short time for this discussion. You see, Stefan Svetsky, he is rather original researcher, and he has such an idea as he told to me. You see, he says, why do we deploy different cloud applications, and after that we consider different aspects of synchronization, of just embedding it into the whole system or something like that, integration, you see. But he says, but Microsoft already done this work for us, because their applications are intrinsically integrated. That's why to build such difficult systems if we can take the Microsoft technology in directly. For example, to take this database, and after that, these databases now may work with different formats, with simply maybe all formats, all possible formats you may insert into database. And if to take it in cloud environment, everything will be integrated in basically. You see, this is his idea, and now he's testing this idea. Some people are so to say, doubts about it. Somebody like it very much, you see, but this is his research idea. That's why you may include into database everything you like, but you need to introduce this information there. For example, you may even automatically fill it, or maybe manually fill it, but you need to fill it. For example, if has shown the example with journal publications. They were organized in the system and were very easy to look through, but still somebody should to fill this database with these journals, maybe automatically, maybe manually, but still you need to fill it in.
Thank you, Maria Pavlovna.
I think maybe some days to continue this discussion,
Yes.
it would be very interesting for me.
I would like to wish you success in this and other your all research.
Thank you very much, and I hope sometimes we will meet in person and we'll have a lot of discussions in these different aspects of this problem.
I agree. Thank you.
Thank you very much. And now we should finish our section, and we are a little bit even out of our timetable. About the next.
13
Aha,
o'clock.
okay. Then, and will be a lunch break, and the next session we will start at 13. So you are welcome for the next session, and now the lunch time.
Павел Пласкора will be lead this session.
Yes.
Okay.
Welcome to the next session. Yeah,
See you
please.
soon. See you soon.
See you soon.